Let me start with a simple truth. The future of networks won't be limited by autonomy, but they will be limited by conflict. And that's because the moment you have network intent, you have competing intent. And the moment intents collide, autonomy either needs to step up or the human needs to get pulled back in. So today, welcome to the future of connectivity. This is the second phase of our catalyst, conflict management in intent-based networks. In phase one, we demonstrated end-to-end intent across a multi-layer RAN network, enabling fully autonomous operations from the business and service layers using Team Forum Open APIs, right down to the RAN resource layer, based on the ORAN SMO architecture with RAPs. One of the most important learnings we took out of that first phase was clear. Autonomous detection and handling of conflicts is one of the biggest barriers to eliminating human involvement. So therefore, phase two, which we're doing now, preserves the intent-driven architecture of phase one, but now focuses on autonomous conflict handling across all network operation layers. At the business layer, we take customer requirements, which are captured through a natural language conversation, and an AI agent translates that conversation into a 921 intent. This intent is then validated with the service layer using the Team Forum 645 service qualification and 641 service ordering APIs. Further, using a knowledge plane that models all the related resources and the future network states. If the original intent is not feasible, the service layer proposes alternative service definitions that best match the customer preferences. Using utility functions, which we embed in the intent, the service layer can generate feasible alternatives that remain as close as possible to the original request, balancing customer preferences with current network conditions. Once a feasible service option is identified, service level intent is passed onto the resource layer for its actuation and realisation. Down at the resource layer, intents originate from two sources. First of all, the service layer intents, which we just talked to, representing the customer and service objectives. Secondly, operator intents, representing network-wide goals such as optimization. Service intents and optimization intents are not always aligned. These conflicts are resolved, though, through the actions of the optimization RAPs, which seek a balanced outcome across competing objectives. The optimization RAP moderates the intent management control loop of the autonomous domain. It will generate proposals considering the operator intent, in this case the optimization, and the service intent. These proposals are then analysed to determine the best outcome, which minimises the conflicts. Another key innovation of phase two is the ability for third-party RAPs to participate directly in optimization intent management loop through a new open agent interface. This interface acts as an open API for agentic collaboration within an autonomous closed controller, allowing multi-vendor RAPs to jointly evaluate intent, learn from outcomes, and contribute to the decision-making. And another key innovation of the project is an authorization scheme using autonomous domains' unique scope of operation. This means that any action towards the network is uniquely assigned to an autonomous domain, and only the authorized domain can act. Enforcing autonomous domain authorization protects the network from cross-interference and instability. Together, all of these innovations demonstrate that conflict handling is a cross-layer concern addressed through intent-driven reasoning, agentic collaboration, and strict domain-level authorization. This catalyst proves that autonomy only scales when it's standards-led, collaborative, and conflict-aware, and that conflict management is no longer optional but foundational to achieve level 4 autonomous networks. Visit us at DTW to explore the solutions and innovations demonstrated by this catalyst in more detail.